Hello, Assalamualaikum. We are from Group 2. We'll be presenting the experiment 4, which is application of first and second law of thermodynamics. This is our group members, which are Abdi Majid, Melvin Chi, Nazirul Hilman, Nurul Nadra, and Hud Muhammad. There will be 4 parts in the experiment, which is introduction, methodology, result, and conclusion. I will be presenting the introduction. So this is the abstract for this experiment. So the purpose is to study the concept of first and second law of thermodynamics. For this experiment, we'll be using beaker and cylinder. The beaker will be filled up with corn oil and the cylinder will be filled up with hot water. So the initial temperature for both was recorded. Then the cylinder with hot water was put inside the beaker with corn oil. After that, the temperature for both hot water and corn oil was recorded for every 1 minute until it reached equilibrium. So the graph that will be that was plotted, which is temperature of hot water and corn oil against the time. So according to the first law of thermodynamics, the theoretical value for the change in energy for the whole system should be equal to 0. So the objective was to apply the first and second law of thermodynamics in various processes. So the introduction. The law of thermodynamics is a set of physical characteristics that characterize thermodynamic systems in thermodynamic equilibrium, such as temperature, energy, and entropy. So the zero law, the first law and the second law, also the third law, are all significant fundamental law of thermodynamics. So the law of conservation of energy, sometimes known as the first law of thermodynamics, says that energy cannot be generated or destroyed. Energy can be converted from one form to another, but an isolated system's total energy remains constant. So for instance, consider the energy change from electrical to thermal energy that occurred in the experiment when the water was boiled using the kettle. So the heat transfer happened spontaneously only from higher to lower temperature substances. According to the second law of thermodynamics, heat can be transferred from a cooler body to a hotter body if system is subjected to external action such as air conditioner and freezers. So the application of first and second law thermodynamics is diverse processes will be the one that we focus in this experiment. So the theory of the experiment, the exchanges of external work and heat complete the energy balance. So the energy balance of first law of thermodynamics is referred to as the conservation of energy principle, which means the energy can be neither be created or destroyed. So the basic calculation of energy balance for the system is as follows. So, according to the Clausius statement of second law of thermodynamics, it is nearly impossible for any system to operate in a way such that the sole result will be transfer of energy by heat from a cooler to a hotter body without an external forces.
Thermo and Material Lab. Today's experiment is experiment 4, which is application of first and second laws of thermodynamics with group 2, Magmuchid Gilawi, and other members are Melvin Chi, Nasirul Hilman bin Mahdi, Sufri, and Nurul Nadra bint Sulkhairi, Hud Muhammad Wassame. I will be present on methodology, which is in here we have apparatus and the procedures. So first we have kettle or the heater, a big container or a small container, containers which are small and big, a balance, electronic balance, a thermometer, and stopwatch. These items are the apparatus we need to have in order to make the experiment. Here we have all tools we need to make which we need to make the experiment. As we have seen the picture, we applied all in the experiment. This one is a container which balanced in electronic balance. There are the corn oil, which is also uh, something must to have. And here we have thermometers and the kettle, the heater, and also the containers. So after that, we present on the see the procedure. First, put small and large empty containers with weight using by the electronic balance. The large container will fleet and was also uh, put it on the corn oil. And here we have seen cold water, but it is corn oil. And the mass of containing container of water is also weighted. The mass of water was charted by substituting the value of mass of container filled with the water with the value of mass for empty container. The small container was also filled with water and was heated until the temperature of the water reached 8 Celsius. On the same time, the temperature of the corn oil were measured. The mass of the container that contained hot water was immediately measured to avoid much heat transfer to the surroundings. The mass of hot corn oil was measured, and CS immediately the hot water that contained hot water was placed in the large container that contained corn oil. On the same time, the stopwatch was set on. The temperature for both hot and cold was jotted down every 1 minute minutes until they reach the same temperature, thermal equilibrium. So for me, that's it. Thank you very much, and I will present the next presenter.
Okay, hi, I'm Melvin, and now I will present the result and calculation for this experiment. Okay, firstly, this is the table that we use to record the data, which the data recorded are time, temperature of hot water, temperature of corn oil, temperature of change of hot water, and corn oil. Okay, from the experiment, the time that we taken is from 0 to 14 minutes, where in the 14 minutes, both temperature of hot water and corn oil reach equilibrium. Okay, so from these two data, we can calculate the temperature change of hot water and the temperature change of corn oil. Uh, this table we're going to use it in for plotted a graph, and for the and also we also will be used in the calculation to calculate the energy change in the system. Okay, so this is the graph that I mentioned before, where this is the graph of temperature versus time. Okay, we enter the calculation part. This is the we have extra data that will help us for this calculation. Okay, the first data is the heat capacity of water, where the value is fixed, which is 4.18 kilojoule per kilogram Kelvin. For the second data is the heat capacity of corn oil, and the value is 1.67 kilojoule per kilogram Kelvin, where both heat capacity data is constant. for both medium. Okay. The mass of hot water used in this experiment are 0.024 kilogram, while for corn oil, the mass is 0.30075 kilogram. Okay. So for the calculation, this is the formula that we're going to use to calculate the energy change. Okay, firstly, we're going to calculate the energy change for hot water, where the formula are mass of hot water, uh, head capacity, and delta T, where delta T is T2 minus T1, where is uh, or is also easier as for understand is the temperature change of hot water. So from the and for T2 and T1, we can get the value from table 1. Okay, we just sub in the all the data inside this formula and we get the energy change for hot water is negative 6.822 kilojoule. Okay, next we calculate the energy change for corn oil, where the formula still the same, but the mass that we're going to use are the mass of corn oil and the temperature change of corn oil. Same as the calculation for energy change of hot water, we just sub the data inside this formula, then we get the value for energy change of corn oil is 1.507 kilojoule. After that, after we calculate both the energy change for hot water and corn oil, we can calculate the energy change in the system, where the formula are mass of hot water uh, times with heat capacity of water times with temperature change of hot water plus mass of corn oil multiply with the heat capacity of corn oil multiply with the temperature change of corn oil, and then we get the final answer is negative 5.315 kilojoule. Okay. Okay. From the formula, from the formula before, we can calculate the energy of hot water and corn oil for each minute, and by that I we plotted the each energy change for each minute into the table 2, and I think that's it for result and calculation part. So I will pass to the next presenter to present about the discussion. So thank you.
Uh, Hello, my name is Nazriman. I will present about this question part. Okay, in this experiment, it was found that the temperature of the hot water decreased more severely than it did on later on. Moreover, we noticed that hot water had a bigger temperature change than cold water. Okay, the rate of temperature change in hot water and colder is shown by the gradient in the graph. When heat is transport from hot water to colder, there will be a temperature differential. Because of the process of hot water losing energy, the gradient is negative. So cooler on the other hand has a positive gradient because to the energy is absorbed from hot water. Because energy is transferred between these two mediums, we can verify that it follow the first law of thermodynamics. We also note that the temperature of the hot water decline with time while the temperature of the cooler increase. The second law of thermodynamics states that heat is carried from a high to a low energy level, and this example proves it. Okay, there will be no heat transfer when the heat and cooler reach the thermal equilibrium. As a consequence, there is no change in temperature at this time and the readings stay constant. The decline gradient in the graph suggests that the rate of the heat transfer has diminished with time. Initially, the temperature difference between hot water and colder is substantial and the rate of heat transfer is faster. So the system approached the thermal equilibrium. The temperature disparity reduced as a consequence. The transmission rate slows when both liquids have the same temperature and no heat conductor for them. They have reached the thermal equilibrium. That's all for me. Thank you.
Hi, Assalamu alaikum, Dr. and everyone. My name is Khud Muhammad, and I'm gonna present the conclusion. In the conclusion, we know that the energy cannot be created or be destroyed, but it can transform from one form to another form, according to the first law of thermodynamics. So the container will obey if the container is well insulated, mean protected the loss of heat. It's found out that the heat energy is transferring from a high energy medium to a lower energy medium, which is the second law of thermodynamics is obeyed. Moreover, the change in energy for the hot water became a negative value because the energy of corn oil is transferred out from the hot water into the water oil, where the change in energy from corn oil is a positive value, and this is the result of the corn oil receives energy from hot water. Because energy is transferred between these two mediums, we can verify that it follows the first law of thermodynamics. We also noted that the temperature of the hot water declined with the time, while the temperature of the corn increased. So, as the second law of thermodynamics states, that heat is carried out from a high to low energy level. This example proves it. So we can conclude that our experiment is success and it achieves the objectives.